Okay, 2 minutes. So what happens if you apply a magnetic field? You have to do that calculation numerically. So let's choose one of the S's. Let's say S equals 1/2. And the magnetization with respect to the saturation magnetization, here's T over theta. And this is when the magnetic field is 0. H field you apply is 0. Therefore, B field is 0 if you ignore the magnetization. Okay? Magnetization is small in comparison with the H field you apply, so it's okay. Now, when you raise the magnetic field, this curve goes like this. You can show this only by doing numerical calculation of the mean field approximation. So now notice when the magnetic field is 0, there's a unique temperature, theta, above which the magnetization is 0, below which spontaneous magnetization shows up. As soon as you apply magnetic field, there's no special point anymore. So this implies, if you look at the phase diagram, in which here you plot either the H field you apply or the total field, B field, doesn't matter, and the temperature, then this is theta. And if the mean field approximation is correct, which is not, and this is the Curie temperature. Here is the ordering, below which the magnetic moment's ordered, right? But now, when you raise the magnetic field, there's no ordering temperature. There's no unique temperature. Sometimes you see a graph like this. Sometimes you see a graph like that, but that's wrong, okay? Because as you can see in this curve, there's no special point. If you see a kink, let's say, okay, then you might say, okay, this is a special point, below which the system is very much like in this region in the 0 field, and about which, well, there's a magnetization, but it's not that different from Curie-Weiss law magnetization. Magnetic susceptibility times H is slightly different, of course, but there's no such a point, okay? So this is what ferromagnets do, not just within the mean field approximation, but ferromagnets usually has an ordering temperature below which you see, the system is ordered, spontaneous order. Such a temperature exists only at 0 field. This is different from antiferromagnet, which we're going to look at next week. In antiferromagnet, there's a region, there's a curve below which the curve defines the temperature below which the system is ordered, even in a magnetic field. All right? So let me stop here, and I give you 10 extra minutes to work on your quiz. And you don't have to stay the next 10 minutes. If you have finished, then you may leave whenever you're done. But make sure you put your name and the student ID. Do graduate students also have an ID? Yes. Okay. Make sure you put your student ID as well as your name.